and maintenance of Polo, Porpoise, and Compo air scrubber systems produced for Big Dutch. Content will be commissioning, user level maintenance, tech level maintenance, and some troubleshooting. Commissioning. The aim of the commissioning is to test and adjust the installation, set up and start use, to train the user, and to hand over the finished product to the client. For this, we use a site acceptance test, or a SAT. The form for this is included in the dealer package. This is mainly for information capture, which will include client's name, project number, the location, which house number it is. If there's 4 or 6 sheds there, then we need to know which shed it is. The technician name, the date of the commissioning. As I say, this SAT form is available to you and will be included in the dealer package in its Big Dutchman version. This document will guide your technician step by step through the commissioning and serve as a record to the test completed with its values. So the first thing we want to test on the commissioning is cleanliness. The system needs to be presentable. So remove all waste from site. Check that the filter pot, the process water areas, the technical room, the control panel are all clean and sealed, and especially the pressure room is sealed. Is there lighting present? It's good to know if the client has lighting, and it is better to have separate lighting installed in case of needing to isolate the power, or if there is a failure on the power system within the air scrubber. Is there ventilation in the technical room? Is it passive or active? Best to record this on the form. So we'll then move on to checking the connections. We need to check the water in, the wastewater out. The pressure differential hoses are all connected. pH sensors are connected and installed, and all taps are opened and closed as required. The float switches, are they installed? Are they connected? Are they working? Are they at the correct heights? And are they the right way up? The Euro system, they are in opposite directions. The minimum float falls open, the maximum float lifts open. So in the standard water level, both switches will be closed as per the right picture. Check that the floats are correctly installed. During the active phase of the commissioning, test the floats. With the power on, lift the maximum float. The high level water alarm on the front of the panel should light up. Let the float drop back to level. Press the reset button on the panel and the alarm must reset. With the pump running, press the minimum float down to simulate a low water level. Pump must shut down and display the alarm dry run. The filter housing. The filter housing comes with a top and a bottom tap. These are to allow water to run back to the filter to the process pit to empty, and a further one at the top to allow air to enter and purge water from the filter housing. Remove the lid by the 6 screw knobs. Fill with water up to the incoming pipe. As you can see in the top of the open filter housing on the picture, that's the opening that you can see. So fill up to that level. Refit the lid in reverse of moving it. This must be done with the air scrubber off. The filter will remain full when the pump is stopped. However, if the filter has been emptied, this can happen unintentionally. Filter must be refilled before restarting the pump. Chemical supply, check the emergency shower functions. Yes, turn it on. It's very simple, but very important. Check the content of the safety cupboard. Is all the safety equipment there? Is it all serviceable? Are the gloves torn, or is the face shield cracked? Is the eye wash used? Chemical supply. Install the acid injector in the pressure line. Refer to the chemical dosing manual, chemical dosing systems manual for more. This is the assembled injector. Comes in a few parts. We slide the collars over the hose, input the bung into the end of the hose, and then screw it onto the injector. The injector will screw into a drill saddle, as pictured, and then a protective housing to prevent any whipping or pulling of the hose damaging the injector is fitted over the top. Pump water through the injector system to test for leaks. And if that works, water is thinner than acid. It's also safe to handle. If you have any leaks or you have any seepages, it's best to have these with water and then seal them up. And you know that because acid is thicker, it definitely won't leak. If you are connecting from a IBC to a specialist double wall tank, then you'll have the quick connectors. If not, then you'll have a lance like in the picture there. Connect the lance up and drop it into the tank. This is installed through the screw-on lid on the top. Connect the chemical dose system, set it to automatic at the end of the test and at the end of the commissioning, and ensure that the pH automatically adjusts. Check the pump stops when alarms are triggered and when it's been running too long. See the settings for further information. On the bottom of the lance there, we have a little strainer pickup and a non-return valve, so that when the tank is almost finished, we can remove the lance and place it in a new tank without having to reprime the acid system. Electrical checks. We need to check the breaker settings so that each motor group is set up for the correct amperages that each pump has fitted. Check all connections are tight. Check the 24 volt, the 220 volt, and the 400 volt voltages. Check the supplies are correct, and any connections to any slaves. The PLC logger is the green light on the front. Big green light fitted to the front of it. If that's on and the system is working correctly, this will be pre-tested in our factory. Record the MAC address that's on the PLC, and after testing, after completing the full test or the full site acceptance test, you can remove the SD card and read the file under the program Excel, Microsoft Excel, and as long as there have been details recorded and that these are correct, you know that the logger is going to continue to log the data as required. With the Moxa modem, connect it to the internet and check that the data is being logged online. I believe that we will have an account set up for you if you require it to access and view the Moxa logged data for your clients. Are there any questions so far? Okay then. Starting up. Clear the air scrubber of all materials and staff. Set the air scrubber to on, and it will now self-test, fill, and start. One of the first things to do is to check the direction of rotation of the pump. This must always be clockwise. In the case that the pump runs in the opposite direction, you must reverse any two of the power phases on the pump. After it's been running for a short time, you can close the flush taps on the end of the sprinkler lines and point the sprinklers down. It's best to do this with the system off. There's our flush taps on the end of the sprinkler lines. Now that we've got the system running, we want to check the sprinklers on the check the pressure on the main sprinklers is half a bar or 0.5 bar. We will adjust the stopper on the BLEMO valve to allow to only allow the valve to open to a certain amount. Once we have the system running at our 0.5 bar, we'll test the amperage on each phase of the pump and check that the pump is running on the pump curve. With checking the pressure, please bear in mind that from the pressure gauge to the height of the sprinklers, you will need to add an additional 0.1 bar per meter of head that you go up. And for the drain cycle, the main pressure line will try to limit or try to close to create pressure on to create a back pressure on the drain line. So we initiate the drain cycle and monitor the flow. We adjust the stopper on the BLEMO valve when we record a flow of around 30 cube per hour. So we allow the valve to close just far enough that it's producing enough backflow, and then we lock it off. We also need to ensure that the flow is being counted. So, apologies. So when the drain cycle is initiated, we need to make sure that the controller is counting. In the overviews, you can view a drain turns and a flow. This will allow you to see what's actually being drained. We'll also calibrate the pH sensors. To do this, we use a pH of 3.07 and a pH of 7 test fluid. We then run the calibration program that is built into the controller under the air scrubber settings. We also need to place the conductivity sensor in a test fluid of at least 140 millisiemens and confirm the reading. Whenever removing the conductivity sensor, take care not to lose the rubber seal. We need to calibrate the flow meter, as we call it, the lead bar. With the system running, we press and hold S2 until the display flashes. The LED on the very right hand side will stay on solid and then start to flash. This will tell the sensor that it is now reading 100%. We need to set point 1 to value 4, set point 2 to value 7. Take care not to cross them over. This is not required for the DLG certified air scrubbers, as we use a different flow meter. Are there any questions so far? Okay. Moving on to servicing. I'll begin with the user maintenance. Weekly user maintenance will include cleaning the pH sensors. So we close the supply tap to the sensor block, remove the sensors, clean them with a soft clean rag, reinstall them, and then open the tap until enough flow is showing on the sight glass to the left of the sensor block. Opening the tap too far will damage sensors over time and reduce the lifespan. pH sensors only have a lifespan of 12 months. Also on the user weekly maintenance, we need to clean the conductivity sensor. In the same way, we close the tap and remove the sensor, clean it with a soft clean rag, making sure that the eye through the sensor is clear, and then reinstall, making sure that the stainless steel pin is into the flow that is coming into the sensor block, and then open the tap until the flow is correct. We'll also need to clean the filter. So the first thing we do is set the computer from on to maintenance. So from on to maintenance. This will stop the pumps but allow the rest of the air scrubber to function correctly. While in maintenance, the air scrubber will record these hours as maintenance hours. Remove and clean the filter basket that's inside the filter housing. Replace the filter filled with clean water. Seal the filter, replacing the lid and sealing down with the 6 hand buttons, relatively tight. You do not need a tool to close these handles. Hand tight is sufficient. On larger systems, make sure they're tightened up as hand tight will go. Ensure that both taps are closed too, and then set the air scrubber back to on. And cleaning of the tech room. Good housekeeping in the technical room will help you find any issues early, and it will prevent corrosion and premature failures. Yearly maintenance. We class yearly cleaning filter package as yearly maintenance. Use the wash hose to rinse the package through. This may be required more often if the pressure difference rises faster. Are there any questions on user maintenance?
No, not from nothing.
Okay. Moving on to dealer or technician maintenance. The first thing that we're going to want to do is to clear any or solve and clear any alarms and get the system running as it should. Record the client's details and record the system number details, system details. So the serial number, the amperage draw across the pump while it's running, the pressure on the sprinkler line, the kilowatt hours used. All these details are also available in a servicing form that we have available to you. In the panel, we need to make sure that the panel is secure and all of the components are secure, the connections are secure. Is the incoming voltage correct? This is also worth recording. And is the kilowatt hour meter recording correctly? Clean the filter, as previously discussed in user maintenance. pH sensors. Replace the pH sensors every 12 months. And these will need to be recalibrated when new, but also at 6 months. So if you're going to a client every 6 months, you want to recalibrate the first time, and then the second time replace and recalibrate. Clean the EC sensor, clean the electrical connectivity sensor, and it's also worth immersing it in a test fluid to check that the value is rising correctly.
I have one question. Sorry, the pH sensors have to be physically replaced with a new one
At 12 months, yes.
at 12 months. Okay, and the calibration is done on the PCB board or inside the software?
With new systems, we have a software-based calibration program, so you won't need to do anything on the printed circuit boards. On older systems, we used to have a method of doing this through the parameter input screen with the old digital readout screen, like a digital clock, and scrolling through the parameters and changing the
Right.
parameters 1 to 0.
Okay.
But it's all been made software friendly now. So as you use the calibration program, the instructions are listed step by step on the screen in German. So you will be able to, or in the user's language. So if it's in English, it will be in English. If it's here, it's in Dutch. If it's there, it's in German. I'll tell you step by step exactly what to do.
Perfect.
The pH sensors themselves are an electrode inside a glass case. So as the electrode is producing a millivoltage, over time the electrode will begin to corrode and be used up. So therefore, they're only considered effective enough for 12 months.
Well, yeah, I have also a question. What are your experience regarding to change this pH sensors? Are the customers doing that every 12 months or not?
Customers in the Netherlands are, because it's known that the pH sensors must be changed every 12 months to be considered accurate, and be calibrated every 6 months to be considered accurate. Therefore, the authorities that are checking sites are checking to see when the pH sensors were changed and when they were last calibrated. And they want to see in the handbook, in the logbook with the unit, that it's written down, changed at this date, calibrated at that date, and countersigned by a technician.
Okay.
Yeah?
Yep.
Okay. The level sensor, the radar level sensor, you can see a cutaway where you can see through it here. This will become a little dirty over time. Although the filling water is shot at it and keeps it clean, it will need to be removed and cleaned. We need to make sure the white ring underneath is cleaned really well. This is where the radar is emitted from, and if there's any foam, dirt, muck clogging this white ring, it won't give a clear enough signal and will not read the water level correctly. The level floats, again, remove, clean, refit, and test. And the chemical system. Set the chemical pump on and watch for a reaction within a few seconds on the pH level. Then switch back to automatic. Put the pump on for 20 seconds max. You should see a reaction in less than 1 minute. Check the anti-foam pump, set it on, and watch the hose to see that it's working. Then set back to automatic. The pump's reaction should be instantaneous. Check the sprinklers are spraying clearly and that the package is evenly wet with no dry spots. And any of the sprinklers are blocked, need to be removed and cleaned. This is considered a user level task, but it can be also done by technicians. It's best to take a bucket of clean water up to the sprinkler room with the system off and remove them one by one, cleaning them in the bucket of water, and then refitting.
What is your recommendation to check the sprayers, the sprinklers?
Visually, you will be able to see very clearly when a sprinkler is blocked. It will either be dribbling like a tap that's halfway on, or it'll be stopped completely, or it'll have a really nice, beautiful cone-like spread. If it's got this nice clear cone spread, you know it's good. And if it's just spraying out of one side, you know there's something jammed in the other side. It's pretty clear when you go and look at them visually if they need attention.
Oh, okay.
And also check the underside of the package and any pre-sprinkling. You want to check the package for any dry spots and check the pre-sprinkling is all working correctly. With data logging, you can either access it online, or you may on the PLC variant, you may need to pull out the SD card and read this off. When you check down when you check through the data that's been logged, you are looking for smooth running. Has there been any sudden fluctuations in pH? Has the kilowatt hours reading suddenly stopped rising and then started again? Has there been downtime? Has there been any issues? If you look through for these eventualities, you may find that there were 2 days that the pH was high, and when you speak to the client, he may say, "Oh yeah, that was the day I ran out of acid," and it shows that you're really looking into the system and you know what you're talking about. On the Moxa modem, obviously you can access this from a distance, and in the same way you can check through if there were any issues, or if there was if there's any history of alarms repeating. And finally, gas testing. We measure before and after the air scrubber for NH3 ammonia, and comparing these two readings, we can get a percentage of how well the air scrubber is performing. Is it a 70% air scrubber? Is it a 90% air scrubber? We need to make sure that we are actually reducing correctly, and if not, why not? Are there any questions on any of that?